You know, tuberculosis has been this relentless enemy of ours for thousands of years. But what if the key to finally beating it wasn't some brand new weapon, but a way to just supercharge our own body's defenses? We're about to dive into a totally revolutionary strategy that completely flips the script on how we fight this ancient killer. First, let's just get a sense of the scale we're dealing with. Every single year, tuberculosis, or TB, is responsible for 1.6 million deaths. I mean, let that sink in. That makes it the world's deadliest infectious disease from a single bug. It's this quiet, persistent killer that is still taking lives at an absolutely shocking rate.
So why is it still so deadly? Well, a huge part of the problem is that the bacterium itself, Mycobacterium tuberculosis, is just incredibly smart. It's constantly evolving, creating these drug-resistant strains that make our old, trusted antibiotics pretty much useless. We're stuck in this constant arms race, and frankly, we need a whole new way to fight.
And that's exactly what's happening. Scientists are completely rethinking the approach. Instead of just throwing more antibiotics at the bacteria in a frontal assault, they're trying to change the battlefield itself. The new game plan is to stop focusing so much on the bug and instead strengthen the very place it loves to hide, our own cells. This really shows you that fundamental shift. On the one hand, you have the old way, antibiotics that are designed to go in and kill the bacteria directly. Simple enough. But on the other side, you've got this new approach, a strategy that's all about tweaking our own immune response to make our cells a terrible place for that invader to live. So, this new strategy has a name. It's called host-directed therapy, or HDT. And you can think of it like this. Instead of just building new missiles to attack the enemy, we're reinforcing the castle walls, we're training the guards inside, and we're cutting off all the supply lines, all by just empowering our own cellular defenses. And the potential benefits here, oh, they're huge. We're talking about maybe shortening those long, difficult treatment times, cutting down on the really nasty lung damage that TB causes, and, this is the big one, completely bypassing the bacteria's ability to develop drug resistance. It's a strategy aimed squarely at the biggest problems we face with TB. Now, to really get why HDT is so incredibly promising, you first have to appreciate just how clever this bacterium is. M. tuberculosis doesn't just survive inside us. No, it's evolved this amazing playbook to actually thrive in the one place that should be the most dangerous for it. It's a really fascinating question, right? How in the world does this tiny organism set up a home and start multiplying inside our macrophages? I mean, these are the frontline soldiers of our immune system, the very cells designed to eat and destroy invaders. Well, the answer is it's a master of hijacking our own cells' internal machinery. The bacteria's plan is it's deviously simple. First, it actually lets itself get eaten by a macrophage. But once it's inside, it immediately gets to work. It starts sabotaging the cell's garbage disposal systems, stopping the formation of what's called the Phagosome-lysosome. That's basically the cellular acid pit that's supposed to dissolve it. And just like that, it turns its prison into a safe house where it can multiply. But our cells are not just sitting ducks. They have a really powerful built-in defense system, a cleanup crew, that M. tuberculosis is absolutely desperate to shut down. This system is a critical part of our cellular defense. This system is called autophagy, which, literally translates to self-eating. And it's basically the cell's dedicated cleanup crew. It's programmed to find, wrap up, and haul away any unwanted junk, like invading bacteria, to the cell's incinerator, the lysosome, for total destruction. It's a fundamental defense that TB has to disable to survive. Okay, so here's the core idea. This is it. If M. tuberculosis survives by turning this cleanup crew off, then our best bet is to figure out how to force it back on. It's all about rebooting the natural defenses that the bacteria so cleverly switched off. And that is the central question, isn't it? That's what HDT researchers are all focused on. And the answer isn't some single, simple button. It's a whole network of molecular switches that control the cell's internal wiring. And the good news is, scientists are starting to identify the master controls. And here they are. The whole solution really seems to come down to two key molecular players. We need to turn off a master switch called the mTOR pathway. The bacteria loves to keep this one on. And turning mTOR off then unleashes another master regulator, a protein called TFEB, which is basically the commander-in-chief of that whole autophagy cleanup crew. This lays it out perfectly. When MTR is active, which is what TB wants, it keeps TFEB held down, and autophagy is switched off. The bacteria is happy.
But when we use a drug to block MTR, TFEB gets activated, it zips over to the cell's nucleus, and it starts turning on all the genes for the cleanup crew. Game on.
And here is where it gets absolutely mind-blowing. By screening a bunch of existing drugs, scientists found that medicines developed for completely different diseases. We're talking cancer, diabetes, all seem to work by flipping this exact same switch. This discovery of a single target means we might not have to invent brand new drugs from scratch. I mean, that could speed up new treatments like crazy. So this convergence on a single controllable pathway inside our own cells, it really feels like it could be a whole new era in TB treatment. So what does that path forward actually look like? Well, the path forward is all about synergy. It's teamwork. Like this chart suggests, when you combine these new host-directed therapies with the old antibiotics, the result is so much better than either one alone. You get this powerful 1-2 punch. The antibiotics hit the bacteria directly, while HTT makes our own cells better at clearing the infection. It just leads to a faster, more complete recovery. So when you boil it all down, host-directed therapy is a true paradigm shift. It's about understanding that intricate dance between the pathogen and us, the host, and then tipping the balance decisively back in our favor by just rearming our own built-in defenses. And this leaves us with a really powerful final thought. The ideas behind HDT, they're not just for tuberculosis. So many other nasty pathogens use similar tricks to hide from our immune system. So if we can master the art of making our own cells stronger and more resilient, what other superbugs, what other supposedly unbeatable infections could we finally beat from the inside out?